something about the structure of the network. So that one is right. Anybody has any questions about the quiz, you should ask me now. Okay. One of the, I guess I gave you these, not that one, just a couple of pages from this person's presentation that they, for a workshop they ran, because I thought it had a nice kind of summary of things we need to think about here. One is that why are you doing a visualization? What are you trying to find out? And they list different things that one could be trying to find out here. We're going to today kind of have a general visualization that tries to show the key actors and structural properties kind of all in once. I'm not going to be really specific about why we're doing visualizations during today's demo, but we will be when we get into using it later in the future. And you should think about that on your homework too. We're mainly going to be doing what they call network maps. And but later in the semester, we will have these temporal analyses where you're going to have time flowing through time, how ants interact with each other, flowing through time, how nurses in a hospital ward, nurses, administrators, and medical doctors interact with each other. So we'll see some other visualizations later in the semester. Today, it's mainly about that. And of course, the main features that we have to work with, position is the big one, of course. This is all about the nodes. How are they positioned? We can color them, size them, shape them. I haven't been using shapes in Gephi. We will use them in iGraph. So we tend to use size to be an indicator of importance, and color is good when it's the hue for categorical information. That's this one. If you do a intensity of color, that's good for more continuous data, like a heat map imposed on a network. Position, our visual system immediately sees these three as being related and these four as being related. Something that the Gestalt psychologists observed 100 years ago or more. Wow, it's going to be more than 100 years already. And we try to respect certain aesthetics. We prefer not to have edge crossings because it's harder to see what's going on. This is like in diagrammatic layouts rather than topological, as the paper talks about. But if there's no other reason to make one edge longer than another, keep them uniform. Try to not have nodes overlap. We have a filter that will apply to do that today. And symmetry tends to fall out of some of the other rules for force-directed algorithms. So those are just some things to think about to get us started with visualization. Let me get set up for doing my first demo now. I'm going to mute just for a second. I'm actually going to redo my sharing because I think that I just want to be able to pop that up without it coming up in the video recording. So let's do a new share with just Gephi, which I already have running. And oh, I don't know if I need this preview. Well, we'll need some preview, so I'll bring preview up. Okay. So if you want to get ready, you can go ahead and start Gephi. Get to this point. Let me just get my voice ready here. Okay, and you can follow along in the agenda. The script that I'm following along is in the agenda. I'm just not making it come up on my screen when I look at it, just so it doesn't distract you as I keep popping back and forth trying to remember what I was supposed to do next. Okay, so let's go ahead and start recording this one.
Recording in progress.
So this is the beginning of demonstration of digitalization in Gephi, and we're going to start by loading 3 files that should be there in your current class folder, the networks subdirectory, as per our usual procedure. So if you gotten here, just do new project. So we've got a workspace here already. First thing, we're going to load 3 things just that we're going to use. Later on, we may get to something else. So we're going to use this tapped in chat sample annotated. That's the one in last week's class where we added a short label and a character count to. Open that one, and it's a directed graph. And I'm going to go ahead and throw that in the current workspace because I've already got one. Okay, and as usual, I am going to rename the workspace. Just remember what it was. And then the second thing we're going to open is network science. There's this severe error. Remember the iGraph, you can name a graph and Gephi doesn't know what to do with it. And so it gives you a severe error. But we can ignore it. It's not severe. It's just not going to use it. This is an undirected graph of co-authorship in network science. Go ahead and put it in a new workspace and rename that. Okay. And the third one will be this internet routers. This is a bigger one. It's in the GML format. And it will take a second for the window to come up. Notice 22,000 nodes, 48,000 edges. It is undirected. And we'll go ahead and put that in a new workspace and not do anything with that right now. Now, at this point, if you haven't increased Gephi's memory, it's possible that it may be hitting a limit and telling you, should I get more memory? And then you have to restart the whole thing if you wanted to do that. Actually, if I look at my activity monitor, I'm only using 590 megabytes right now, but it may increase as we do layouts and stuff. Okay, so the first thing we're going to look at, well, we're going to look at layouts. And so I've deliberately chosen different sizes. There's 3 different sizes and 3 different kinds of structures. Maybe I better just remind you, TI chats, if we go into data laboratory, remember this is actually an actual chat session from something in the 2000s where I wrote a program that figures out relationships between chats, that each node is a chat message, and a chat message is related to a previous chat message if it's close in time and some other conditions to hold. The other person's name is used, some of the same words are used. If somebody says mentoring and then 15 seconds later somebody else says mentoring, then they're likely to be related. If it's the same actor, the same person saying something twice, the second utterance is probably related to the first if they're close in time. So things like that. I wrote this program that applies all these rules to try to find the interactive structure of a chat, because sometimes chats can have multiple conversations going at once. But it's a small graph and it's directed because each chat refers only to previous chats. In fact, it's a DAG. You can only refer to things that happened in the past, not the future. Net Science is a little bit bigger. This one is a network of authors in network science as of, I think it was might have been about 2005. It misses a whole lot of people that are important now, but it's a nice simple graph with structure that we can understand. And has the extra advantage of some of these people are going to be authors that we will actually read. And it has weights between the edges having to do with the nature of their co-authorship. It's a co-authorship network. And I'll discuss the weights in another class. And then the third one, which I forgot to rename, is routers. And this one, unfortunately, did not come with any information about the routers. It's just a big graph. It's the edges are undirected. There's no weights. It's just an example of a big graph, and we know something about the internet, so we'll be able to at least have some vague interpretations of the results. So pause for a second, make sure everybody has got their stuff loaded.
Recording stopped.
Anybody have any issues? I'm going to move along fairly quickly, so maybe I'll just give you a chance to catch up. Okay. All right.
Recording in progress.
So now we're going to look at some layout algorithms. The classic one is Fruchterman-Reingold. It's your classic force-directed algorithm. So go here under choose a layout and go find it. Those are the two people who made it. This is just the basic nodes repel each other. Edges are like rubber bands that pull the nodes together. And there's an overall gravity that keeps things from flying off to infinity. Gravity, it just pulls everything to the center. So it's fairly fast with a small graph like this. It starts from the current layout. It doesn't redo the layout. And it keeps running until you stop it. Notice you're not really seeing linear structures in here. You can grab the nodes and move them around. Try to get it to lay things out a different way if you want to. I'll go ahead and stop that. Now, if we run the same thing, Fruchterman-Reingold on network science, it's going to be slower. It's the big O on this algorithm. I don't know what it is, but it is a slower algorithm. And you can adjust the speed, which the comment down here says there'll be a precision loss, so we can speed it up. Now, if it goes off your screen like that, this magnifying glass right down here, you click on that to recenter. And now once you got it spread out more, you can put the speed back to fine tune it. You can change gravity to spread it out more or pull it more together. And it also continues running. So just to give it a little variation, let's make node size. This thing up here, I did show you some of this last week, but this thing up here is an icon that shows 3 different node sizes, and use a ranking degree. And this is a very common thing, set node size to degree. I increase mine. I think your defaults are smaller. I increase my min to 10, my max to 100, just to make things more visible. And that's what I use all the time. And apply that, and then we get bigger nodes. It's still running, so you see that they do overlap with each other. I guess I'll go ahead and stop that. But what kinds of structures do you see here? Well, you can see there's an isolated group here. There seems to be a large group in the middle, but it's kind of obscured by there's all these other little groups that are kind of packed in around it. There's possibly another isolated group. So it starts to bring out some of the structure, but it could be better. Let's see. I just noticed my my agenda says TI associogram. I was thinking about changing it. It's actually TI. Let's take this one out. It's not. Yeah, I'm not doing that one. I took that out of the demo. Okay. Now next. I would say don't try this on routers. It's just too big, too slow. We've got better algorithms for routers.
Recording stopped.
Okay, I stopped recording to look at the chats. Okay, I'm not going to get into the details of why is that 1 point. Maybe there's some extra edge. I don't know. We're not going to get into details here because this is a tight timeline. Can you give increased Gephi thread count to run the algs in parallel? I don't know whether Gephi, it might, it actually does run threads. So that's, I don't know with the algorithms themselves, which ones actually have parallel implementation, but Gephi does run multiple threads to do different things. So that would be an interesting thing to investigate. Okay, whoops. Let's, all right. So now we're going to go to, oops, resume.
Recording in progress.
Now we're going to go to Force Atlas 2. This is a good general purpose algorithm. And it has some parameters we can control. It also starts from the current layout. So if we go back to this one and we try Force Atlas 2, this is the one that the paper mentions as being good. If we run it without setting anything, immediately we see that there's a linear structure that Fruchterman Reingold was not telling us about. And one thing that it has is this prevent overlap if you just want to spread those nodes out a bit. So that's kind of nice. I'll go ahead and stop that. You may notice that there is somewhere down here a non-overlap filter. You can try it sometime, but don't do it now. It almost always crashes or hangs. I was hoping that they would fix it, but I tried it again last night and it hung Gephi. So let's move on to looking at NetScience with the same layout algorithm. Right now we're just doing layout. We'll get to things like colors and labels in a bit. So let's do FR on that one. And immediately we see we've got better visualization of structure, but it's kind of getting kind of big. Spread out. We can hit prevent overlap at the end to spread them out nicely and then stop. A couple points I want to make here. One is how do you zoom in? Well, hopefully you have a wheel on your mouse or the equivalent gesture on your tablet. So just the wheel zooms in. And so now we can see much better that there was a big thing in the middle, but we couldn't see it with FR. It gets separated out. And that group over here is right there. Maybe somebody might have been asking about that one node that's it's not as connected as the others, so it's set off to the side. Now, so that's one point. You can use your mouse wheel to zoom in and out. And if you get lost, you can use right click drag to move around. If you get lost, you can always go back to this magnifying glass and jump back. But one point I want to make is don't turn in visualizations like this in the class. This is I just ran it using the default values. And if you just run stuff and turn it in because, oh, that's what the algorithm gave me, and you're not thinking about how you're using this visualization to communicate with somebody else, then you're not being a very good data scientist or whatever you want to be. We can group this together more tightly to use space better. We shouldn't force people to have to zoom in so much to see stuff that's all spread all over the place. And I'm going to make similar comments about things like edge arrowheads, if it's directed, node labels. I've had students turn in assignments last year that I actually had to increase the magnification to 1,600% to see the labels they had. That is ridiculous. They had all this space and really tiny labels. Use the space that you have. Okay. Moving right along here. So how do we pull it together then? Well, we can increase the gravity, and that would be done right here. By the way, prevent overlap slows it down. So if you want to speed it up, uncheck it, run it. When it stabilizes, just finish it off with a little prevent overlap at the end. A bigger graph, turn it, especially bigger ones, you want to turn off prevent overlap. Same is true of labels. If you've got text labels displayed, it slows it down a lot. So turn off labels. Okay, so so you can see now that structure is more visible. Now, one thing, this is all starts from the current layout. If I restart from a random layout, what happens? You can go here and there's a random layout, and that puts us back basically to the structure that was there when we first loaded it, although now we have different node size. Now, if I go back to Force Atlas 2, it still has the settings I had. So I'll run it again. And of course, I got to zoom out. There, I got to turn off prevent overlap because that slowed it down. Okay, now turn prevent overlap back on. And notice it's oriented differently, and the positions have changed, but the same structure is there. And that gives us some confidence that these structures are real. It may look a little bit different because this time we started from random rather than starting from what Fruchtem and Reingold had done. And so one point is sometimes you can experiment with layering layout algorithms on top of each other. You know, do one and then do the other. A very common situation for that will be on big graphs, OpenORD. Oh, one other thing is the linlog mode that you read about in the paper. And I find this visually pleasant, and they argue that linlog is optimal. But I find turn off prevent overlap so we can speed up a bit. There we go. I find linlog to be a little bit more angular. You know, that for some reason when the nodes are spread out, everything looks more angular. But it makes better use of space, is their argument. Like it's filling in the space around things, which may make it harder for you to see the clusters. I don't know. You can decide for yourself. Like if I turn that off, the clusters get pulled in. And so in a sense that space is wasted, but it also makes it easier to see that that's a really separate cluster. Okay, we're going to move on then to OpenORD. So we're going to go to routers and okay, go to routers. I'm going to just right from the beginning, I'll set node size to be degree just to give it a little variation here. Looks like there's a big important node right there in the internet that happened to pop out. Now, Force Atlas 2 will work on this. I think, yeah, I guess we'll go ahead and do that. We'll go ahead and do Force Atlas 2 with the defaults and give it a little bit of time. So it's a little slow, but it gloms things together. You can hit prevent overlap at the end, maybe to spread it out a bit. So this does work, but we get kind of this hairball structure in here, and we know that we can see in here that there's important nodes that are sort of being buried in all the things that they're connected to. We can turn on linlog to spread that out some more. Now they're not overlapping so much, but the problem is it starts to grow kind of big. And notice how we're getting a square box kind of effect around the edge there. That's because we're actually hitting the edges of Gephi's space. And when you see that, you got a problem. You're spreading out too much. And maybe you need to increase the gravity quite a bit to get it all to come back in together to something more reasonable. But now it's been kind of messed up because we filled out this square space and some stuff's left behind in the square. So I would actually just restart that whole thing from random. But a better thing for really big graphs, this is sort of on the boundary of big graphs, you know, Force Atlas is working okay. But a better one for big graphs is OpenORD. This is a hierarchical layout strategy. It does sort of like coarse clustering before it does finer clustering. And it is based on an analogy to simulated annealing in physics. So it's got these phases that I won't try to explain. We'll just run it. It starts with putting everything in the same position. If you look down here, you can see the percentage running. So on this graph, it doesn't seem that much faster than Force Atlas, but on larger ones, trust me, it is. And when this hits 25%, it's going to hit that expansion phase, and you'll suddenly see it start growing. So there it goes. And then when actually when it hits 50%, even though that says cool down, I tend to get more expansion there. This one I have found has been pretty good at finding community structure in some types of networks. And it's interesting because the hierarchical strategy that it uses is the same as the hierarchical strategy of a common community detection algorithm called the Louvain method. That's what you get if you click on modularity in Gephi. And they tend to work together well to run OpenORD and then color nodes by so-called modularity, which is kind of a misnomer, but I'll get into that. Modularity is the metric, not the algorithm. They shouldn't have called it modularity. They should have called it Louvain. Anyway, here we go. We're getting almost done. And okay, well, it's running. Pauline has asked me about the 3 files. Yeah, well, I explained at the beginning that TI chats is a relationship between chats. It's a small directed graph. NetScience is authors who are, the relationship is co-authorship of papers, and internet routers is the routers, how the routers and the real internet are connected to each other, which I think we used as an example in the first week. So here we go with the final OpenORD layout. You can see it really shows the structure more, although there is a lot of stuff kind of overlapping there in the middle. Sometimes I will go to Force Atlas to turn on, I better reset all these other things. And just go to prevent overlap just briefly enough to go like that without messing up the structure. Yeah, it's something you can play with and see what works. Okay, so the last thing we need to do on this video is to look at some of the other visualization features. So let's go to NetScience. So here's the a node is an author and a link is they work together on a paper. And so we've already sized it as degree, which is people who co-author with many other people. That's why this group, they're all big, even though they're isolated, because they all co-author with each other. You can see that they're all, they wrote some paper where they're all authors on. But who are these people? Well, if we turn on the labels, it's going to be hard to see against this black background. So let's go to this color palette up here, and it defaults to a nice gray, and apply that. And then if you go down to here, there's a T, click that to turn on the labels. Wait a minute. I have to look behind my computer to make sure I'm clicking on it. There we go. And then there's a little slider over here, which is bad design because they should have made the slider that controls the label size be next to the thing that turns the labels on. You know, this is bad HCI design for grouping, but you can make the labels fit what you want there. You can also control label color. I almost never do this. Using this thing here, you can color labels according to some attribute if there was something available. You can control label size. For example, make the labels on the bigger nodes larger, like that. And then you might have to scale that as needed. Now notice there's Barabasi, there's our main textbook author, there's Newman, our other textbook author, Easley and Kleinberg. I think it was, which one's the computer scientist? Kleinberg is in here somewhere. But that's how to see who's there. Now, what about color? We go back to the color palette. The only option is ID, meaning give every person their own color, which isn't very useful. Why don't we try to color these clusters differently from each other? So if we go over here to connected components and run that, that's going to find the number of connected components in the network, which turns out to be 396, separated graphs. But after we've run that, now back under this color palette here, under partition, it has now put component ID as an option, and it gives you a default colors for the different the top, I forget what it is, what 8 ones. Now they have this dark color that makes the labels kind of hard to see. So I like to change the colors. The way you do that is with palette, and I've got some recent ones that I reuse. And then you go to generate, and you can say like, I want the top, whatever, 25, 30. And you can choose different colors. The one I'm using now, I don't know why they call it this, but it's called Pimp. It has these kind of nice bright colors. You can also use the pastel. Um, maybe, well, now if I just click OK, nothing happens. I did something wrong. That's because when you do this, we have to start over. Maybe I'll change it to pastel this time. You got to click generate, and that shows you what the colors are going to be. And then click OK. But it still doesn't apply it because now you have to say apply. And now you can see it gives each cluster some nice colors to help you visually separate them. Those text labels are still a little big, so I would probably bring them down a little bit like that. All right, let's see. I'm supposed to be wrapping this one up now. And so this is an example of using color for categorical data. So that's the real basics. I'm going to stop the video there.
Recording stopped.
See if there's any unanswered questions. I'm going to continue with these graphs, but I just wanted to break the video up into pieces. Okay. So the next video is going to be, see if I can finish this by 6. I'm going to just show you some more layout stuff. And just some other layouts. That's basically it. And then I want to leave enough time for how do you make images in Gephi. So I'm going to make myself stop at 6. Let's see. I'm just reviewing my notes here. Okay. Circular layout. Yeah, you can find. Okay. Okay. We have one chat. How to make different background color. Background color can be done when we do preview and we're generating images. I don't generally do it here. There probably is a way. Okay, let's start a new video.
Recording in progress.
So continuing the demonstration, now we're going to go, we're going to use the TI chats, which frankly, I almost replaced this because it's not a typical structure. This is a linear structure of how each chat responds to the previous chat, but it's small and, lets us fool with some stuff. So as I mentioned at the beginning, the semantics of the edges are that each chat message has some edges pointing back to previous messages. If you look carefully, you notice that the numbers, this is the from to, the to is always smaller because it occurred earlier in time. And because it's how one chat relates to another. So if we decide to size these nodes, we could just size, do node size by degree, but what does that mean? Well, that just means a chat that is either referenced by a lot of other chats or references a lot of other chats. And sometimes you might want to separate in degree and out degree, which have been already computed here. Actually, you would actually have to run something to get them computed. Well, maybe Gephi does it by default. Actually, that might have changed. Anyway, let's worry about that later. So what does in degree and out degree mean in this context? Well, out degree means a chat that referenced a lot of other chats, and in degree means a chat that was referenced by a lot of other chats or responded to, or whatever concept you think has been encoded here. And I would argue that in degree shows importance because somebody can just blather a lot and mention a lot of things other people mentioned. Well, maybe that's good for pulling things together. But in degree means other people picked up what you said. So what you said probably matters for the continuing discussion. So we apply that, and there you go. You got node size by in degree, but of course it has just messed up the layout terribly. And you could just say, okay, just run it again with prevent overlap. We're kind of starting to lose the linear structure here, though. I'm using this as an opportunity just to show you some other layout algorithms. There's circular layout. and you can choose by what it should be laid out. The default is node ID, but this thing has a timestamp on it, a time attribute. So if I do that, this is now laid out by time in a circle. Somewhere up at the top there, there's a gap between the first and the last utterance of this session. But it might be kind of hard to see the structure because all the edges are kind of right packed together. So you might want to run some kind of force directed thing quickly that separates them. And Force Atlas would really just totally mess this up. And I found out this Yufan Hu proportional is kind of interesting. It does start from the existing layout rather than starting a new one. And if you just run it briefly, it will, it actually runs again every time you click it. I just clicked twice because I was trying to stop it, but I forgot that it stops itself. So, just running circular layout once and then running this Yufan Hu proportional once keeps the linear structure. So that's just an example that you may want to explore different layout algorithms when you have different purposes. Like here, we want to see the linear structure more. Let's turn on the node labels, and of course we're not going to be able to see them well because of the black. But remember, last week we computed the 20 character prefix of the chat to be the label. We put that here. So how do you develop these skills is just that. But of course we can't read them, so we got this gray thing here. We can do that, and now we can see them better. Maybe we can drag things apart if we manually, if we want to improve the layout manually. Okay, but what other colors could we use here? What else could we base color on here? Oh, I'm jumping ahead. I want to do something with the labels first. So suppose we wanted to add timestamp to the labels. You can do different things with the labels. Down here, this little clipboard with I think that's a wrench. I don't know why you need a wrench on a clipboard. The metaphor doesn't make any sense to me, but such is the nature of icon design. So you can add another thing to it. Oh no, I just noticed that the video is not showing the things that come up. That is crazy. You're not seeing the pop-ups. That must have been very mysterious to you. Let me try stop share and restart share. I should have paused for this. Gephi, and see if that fixed it. Wow, okay. Anyway, this clipboard thing, and it does not come up in the, yeah, I need to share the whole thing. That really screws up our demonstration here. I had no idea that that was happening. I thought I could be selective here. Okay, let's just share the whole thing. So this comes up, and yeah, I can set it to be time, and that gives me the timestamps being part of the labels. That's unfortunate. The whole previous video, you didn't see anything that came up. Okay, so you can make that change. See, I was trying to avoid this, where this thing comes up and covers up what I'm showing you. So let's color the nodes. So there's different ways we could color the nodes. Like these are by different actors. You could say I want the. I wonder if this part was probably okay. I can say color it by actor, and there's the usual thing. The palette is. You can pick a recent palette. The palette is only has 8 values, but you can reuse a palette. So now we've got the different actors have their own colors. But you might color it by other things as well. There's the thing we did with the other thing. The other graph was running components. And so there's 100. See, there's 30 weakly connected components. It's a DAG, so each node is its own strongly connected component. There's 171 nodes and 171 SCCs, but 30 weeks. So you can color it by that. Now that we've run that, use that one and some palette, but basically it's all one giant component. So that's not that useful. Maybe sometimes I run community detection on these things to find like parts of the cluster that are related to each other, which might correspond to parts of the conversation. Another one is character count that we computed in class last week. So let's do that. And this is a continuous attribute. So I'm doing it under the wrong thing. I just looked at it under partition. I should do it under ranking. And say I want it to be a heat map, and you can choose different color schemes, you know, like go from yellow to red, or, you know, whatever. Like maybe we'll choose that one. So the darker it is, the longer the chat was. And now you can see, oh, like here's, that looks like the darkest. This is a long chat. And you can then right click on that and go select in data laboratory, and you go to data laboratory and see who had the longest chat, if that's what you were interested in. Okay. Right. Let's check the script here. Oh yeah, let's make the arrowheads visible. So quite often in the default visualization, the arrowheads are ridiculously small. You know, again, I've had to complain about students turning assignments where I had to zoom in over 1000% just to see the arrowheads. So there's two, well, the easy way to fix that here is to drag this slider, which is not the text size, it's the edge thickness slider. And I don't know if you can tell that they actually got bigger. They got a little bit bigger. When we do the export thing, we're going to be able to have more control over that. Okay. Oh, if we click on edges, actually, there's more control over here. You can rank them by weight. I don't see a way to change the size here. This is all about color. Okay, 548. Let's look at some other layouts. So as I said, this is not a typical network structure, but I'm just using this one as an example because it's small. I already showed you random. You can restart things by random. I already showed you circular, and I showed you the you know, the UFON WHO proportional. There's a radial axis, which is kind of interesting. I'm going to go back to node color partition by actor so we can see the different actor. I'm going to give it a different palette here than I used before. Color is easier to see in the video. And I'm going to go to this radial axis layout, which is kind of an interesting one. And you have to decide how to group the nodes. The default is usually not very interesting. You usually do this when you have attribute data. And so I'm going to group the nodes by actor. We'll leave everything else to default. And so that's what a radial axis layout is. Each actor is on their own axis, right? And then you can, I'm wondering where Maria is. I was going to do something with Maria. You can reorder them by time. Oh, within the axis, it's ordered by degree, which is scrambling time. So it might make more sense to order nodes by time for this application. So bigger degrees are utterances that had more of an impact because other people picked up on it. So this makes more sense. Now this one, if you look carefully at the times, the later times are in the middle and the earlier times are on the outside. And this is actually the first utterance right here. Select in data laboratory, and we see Maria. This is how she started the conversation. She was the, this isn't her real name, but she was the facilitator of a bunch of teachers talking about how do you do mentoring of peer mentoring in schools, is what the conversation is about. you can change the direction in which it's, you can make it descending order. This stuff's kind of mashed up in the middle, so those things ended up in the middle there. You can say, well, maybe a spiral is better, so it just puts a little curve in it like that. Okay, what else is interesting here? Oh yeah, I just had a note there to clean up the interval is a time thing that's never used. If you want to get rid of some of these, ID here is, we're not paying attention to IDs. You can get rid of columns just by unchecking them here. And there is a limit on number of columns you can show. So sometimes when you got a lot, you have to uncheck some to get the other ones to show. Okay. The next thing I was going to show you was the rotate. This is a nice one to do rotate on. This one actually kind of landed in a nice position, but suppose I wanted that to be vertical format instead of horizontal. This is kind of obvious. Just go to rotate, and you can change the angle. Run it 90 degrees. Maybe that's not quite as far as I want, so I'll just hit it another 5 degrees. So that's how rotate works. And the ones to look at here, dual circle and circle pack. Dual circle will, but this is not so much about the force directed thing. This is a completely different kind of visualization. If you want to really separate nodes by some kind of attribute, but then see how those attributes relate to each other. And so usually it's the links that cross between the categories that are the most interesting. Although by putting this curve in here, we can see links, within a group too. Because in the way I constructed this data, if an actor chatted close together in time, I linked their chats to each other's. So these chats are linked to each other. But it's really different than the force directed, and so are these other ones. This dual circle layout, I'll just run it, see what it does. Spreads it out, so we got to hit this little thing. It's ordering by node ID. Well, that's not very useful. But maybe you could order nodes by degree. And what that would do is that puts the most influential chats in the middle, because we used in degree. And so that's the chats that other chats responded to are these 4 chats in the middle. And what did they say? I suppose one could. I wish, if you want to actually see it in here, of course, you can go to your clipboard with a wrench and you can turn on contribution instead of the other ones. And then we'll have a whole lot of text on the screen. But at least we can now actually read the full thing that they said. I suppose one could learn to ask the questions. Is it possible a mentor might do this, but not ask these questions about his or own practices? Could this person be a good mentor? They're really getting into the attributes of what being a good mentor in a school is. Some people are excellent teachers, but are horrible mentors. That kicked off a little bit of discussion. And so on. Anyway, we don't need to elaborate that. I'll go ahead and go back to just my short label here. Okay, so oh yeah, you can increase the upper order count. There's 2 things you can do. You can say, well, I want more of the important nodes in the middle. So okay, here's the top 7. You can also reverse it, but put the nodes on the outside. I think that wastes space, so, but you can do that. The next one we're going to do is the circle pack, and this one is like a hierarchical clustering kind of thing by attributes. We're going to circle pack first by actor and then by in degree. Doesn't really make sense. I mean, it's not something I would do with this data when publishing it or anything, but it's just to show you what it does. Let's do circle pack. Whoops. And the first hierarchy will be by actor. So that means, You will know what circle pack is as soon as we do this, because you've seen these before. The second hierarchy will be by degree, and run it. So you see it's made clusters where this needs to spread out a bit. It's kind of, I'm going to go to, expansion. This is something I was going to show you later. You can run expansion just to spread things out a bit. Let's go back to our circle pack. So what you see it's done here is it's something doesn't seem right. Oh, we want in degree. Sorry, in degree, because that's what we're using. There we go. Now it's really clear. So here's all this green person, whoever this is, their chats. By the way, you can hit this arrow question mark and click on a node. And then you can see all the attributes, and that's Maria. Sometimes that changes. Now I can't drag the nodes. If you want to drag the nodes, you got to go back to this arrow here. And actually it's the hand. Sometimes it takes me a little while to figure this out. But anyway, you see what Circle Pack does is it does the larger, it's laying out in circles. So here's a bunch of big circles, and each circle has all the nodes with one actor. And then within the circle, it groups it by the next attribute. We didn't have anything else that was really categorical, so I had to use in degree. But here's the highest degree node, the next highest, and so on are all grouped together. It's not something you really want to do, but it was just a quick way to demonstrate this. If you knew that you wanted to separate nodes by some big category, actually an example I had was with our class contact data, grouped first by whether you're in 422 or 622, and then the next one by something else. Anyway, that was the department you're in, and then that would show you how the department's distributed across the classes. I've already shown you expand, contract, so I think we're almost done. I was going to do it on this one just to, besides expanding, you can also go up here and do contract. Say you want to tighten it up a bit, which is actually a little bit ugly, but okay. So that is the end of that one.
Recording stopped.
Any questions? I'm a little concerned about that whole demonstration I gave you. You didn't see the pop-ups, but the pop-ups only come when I run clustering coefficient. No, sorry, connected components. This is what you missed in the video. I guess it's not a great disaster. You missed it coming up and saying that there's 396 nodes, but if you ran it yourself, you saw it. Nothing else was pop-ups, right? Okay, maybe it wasn't a great disaster. I have to redo the video. Okay.
I had a question.
Yeah.
So how would you set a different background color and then a different text color?
Text color is nodes. Sorry, it's this one here. And you have to choose, I don't know, like that. You'd have to figure out how to color it, and that would probably be pretty ugly. There's different text color. Background color, I don't know, I've never done it. I would caution you against, just be careful unless you've got training in graphic design and you understand, or perception, and you understand how to make things readable. Like this just made it less readable. This is not a good idea. A lot of students like to make the background black, but it's actually harder to read small text on a black background. And also, if somebody has to print it out, it burns up their inkjet printer. But I have not figured out the background yet on this one. Okay, I want to undo what I just did here and then start the next demo, which does take 15 minutes. Let's go back to, hopefully this is text I'm changing here. Yes, okay. All right, a quick check in chat. Okay. Oh yeah, 396 on the right. It does say, by the way, when you run these things, you can click on this little question mark over here, which is going off the screen, to get the report back without rerunning it. And somebody posted a link about changing the background of graph. Okay, I'll look at that later. Okay, we are now going to start another demo, which is really important for your homework, particular, as well as anytime you want to publish something, which will be making images in Gephi. I think that this will end well before the end of the class, and I will have you start an activity, and then we will run out of time, and then I will post you the solution, because there's 3 really aggravating things that you're going to encounter in running this example with it. I changed it to a different graph. Anyway, that's my preamble. So let me get my mind set here for what am I doing here before I start the recording. Right, do that, and then okay, so here's my net science. I could probably improve this layout, but let's say we decided that this was a good layout. We had finished up with Force Atlas 2 with a little bit of prevent overlap. I'll just make sure it's cleaned up there. Okay.
Recording in progress.
So once we've gotten a layout that we think we like, how do we make images that we can put in the reports and things? Easy thing to do is go down, there's a little camera down here, click on that camera. You notice there's a progress indicator here. It takes a little while to convert it to a screenshot. And it comes up with this. And I'm gonna go ahead and write over the one I already did, just to, it doesn't do that. It doesn't let me select that, okay. Oh, that's odd. Anyway, it was selecting my mouse is off by one thing. It was selecting that when I selected network library. Okay, so it was saved. Let's go to preview and go open that thing, which is right here. And then looks like it's good, but this is bitmap, PNG, TIFF, you know, bitmap doesn't work, doesn't let you zoom in. So it's okay to use bitmap if you want a small image as part of a report where it isn't necessary to zoom into the details. Or, you know, this could be like the preview of something that's in an external file. We'll talk about that more on Thursday. Like if you make an R Markdown document and you want to preview in the document what's out in a separate PDF file. But so how do we make that? How do we make that separate PDF file? Well, we go to preview. Well, that's not very helpful. There's nothing there. That's because in order to use this, you have to click refresh down here. And there it is. Well, there's some differences though. It does have the same layout, roughly speaking, but it doesn't look exactly the same. And so there's things we have to do to make it look the same. One of them is node labels. Let's show the labels. Every time you change something here, you got to hit refresh. Now, there's something weird here. Those are pretty big labels. Remember over here, we used this to make the labels proportional to the degree. That's why they look bigger on that one than the other ones. Well, in preview, if proportional size is checked, it's applying that mapping again. It's applying the proportional scaling to the proportional scaling. So you got to either do it only in overview or only in preview. So I'm going to turn it off here, and there, that's a little bit more reasonable. You can scale the text size. If I hadn't done an overview and I had checked proportional size here, it would still have really big labels. And so I almost always have to go into here and choose like the smallest possible font when I'm using this proportional size here. I think here, I'm not sure what the font is right now. Let's just try something. Okay, 10 looks like kind of what they got there. You know, so you can just, oh, you know what? I got the wrong idea here. I changed it, but I forgot to hit refresh there. Okay, so maybe 8 will make it a little bit smaller, hit refresh. Okay, that's starting to look a little bit better. I'll go ahead and just leave it at that. But another thing is the edges are hard to see. The show edges is checked. We can increase the thickness, maybe to, I don't know, just try something. Is that too thick? They are weighted, so the thicker edges mean it's a little slow display here. That means that these two collaborate more. They co-author a lot. This is a co-authorship network that we're going to be using a lot this semester, by the way. So, okay, it's interesting that those are in there. Anyway, what's the next thing we wanted to show here? Labels, proportional edge thickness. I went up to 5. Okay, I think that's probably it here. Let's see. There's other things we can change here. In fact, one thing you should probably know about right away, notice the edges are curved. You can make them straight if you like straight edges better. You're going to be able to adjust edge arrows, but this is not a directed graph, so there's no arrows. There's a bunch of other colors you can play with. But suppose we got this to where we want. By the way, reset zoom down here is how do you get it back to centered. How do we actually make PDF out of this? Down here, export SVG, PDF, PNG. These are 3 different formats that are all structured vector graphics, and forget what PNG stands for, but they all enable you to scale in because they don't just color bits. They have a description of the image so that when you zoom in, it can regenerate the image at the resolution that you're zoomed in. Here, I want to rewrite this out as net_side.pdf, which I already did. PDF, but there's some options here. By the way, here's where you can select PNG or SVG. It defaults to A4. This is actually a kind of a symmetric, a square image. So maybe I want to just do custom and just make it 8 by 8 inches. Portrait landscape doesn't matter. And so go ahead and save. I'm overwriting the one I already did. And now let's go to preview and open up the one we just did. And there it is in a square thing. I guess somebody wandered off up here, so that made something you might want to do when you clean up your visualizations. Why did these guys wander off? Maybe it was part of the whole process. You might pull those stray nodes back in just to make it a little bit tighter, or crop if you don't think anybody will care. But now here we can, unfortunately, preview doesn't use the mouse wheel to zoom. It uses it to scroll. So I've got to click on that button there. But the point here being that even zoomed in all the way to the maximum resolution you can do in preview, everything is still sharp and readable. And I don't know what this resolution is. It doesn't tell me. In Adobe, I can zoom in arbitrarily. I've gone, like I said, 1600% to find something that a student didn't make very visible. So that's the idea. That's how you export high resolution PDF. So often on our assignments, you're going to be making an R Markdown document, most likely, although sometimes it's in Google Docs. And you may, if it's a visualization of a big graph like this, I may want you to do a thumbnail like we did with this, maybe even smaller than this to embed in the document, but then reference the, I'm trying to find it, have also in your folder that you turn in the full scale PDF in case I need to dive in and look at the details. Okay, so I think that was the end of the preview part. And now I want you to do an activity in which you make a PDF of this sociogram thing here. And I'll go ahead and get us started on that, but we'll make a new video for actually doing it. Because we're probably not going to finish. So I want you to open TI a sociogram sample. which is kind of bigger than network science. It is a directed graph, and we'll put it in a new workspace. I will give you a little preview of the meaning of this, which is this other thing that's been popping up here. This is a online community where people could chat live in chat rooms. They could post in threaded discussions. They could share files. And it's a directed graph according to read-write relations. The graph is weighted according to how many times they, for example, chatted in the room or posted in the threaded discussions, or how many times that they actually read something. We have to define what read means. But the point is, it's a bipartite graph. It's multimodal because one partition has different kinds of things. It's directed by read-write relations. And by the way, this is a dependency relation. This means the actor read the threaded discussion. Therefore, the state of the actor is dependent on the threaded discussion. And it's weighted by counts. So that's just so you know what that means. And so your task right now is to figure out a good visualization for this and generate PDF of it. And you're going to run into a problem that I'm going to show you how to solve in a video that I will make later.
Recording stopped.
So that is the end of the recording, and we have a few minutes for you. You should start trying it. See if anybody has any problems. I want to make sure you can. This is a chance to make sure that you can do, if you weren't actually following along, you could do yourself what we were doing here. So go ahead and start it. I'm going to read this thing that Taryn posted here. Portable network graphic, thanks. Oh, it is like a bitmap. Yeah, I thought so. I was wondering why it was on that list. I guess they give you the option of exporting something that's bitmapped. Yeah, okay. Anyway. Okay, so hopefully you are loading that and trying it out, because this is your chance to ask me questions if you have trouble with that. The bulb, okay. I'm just gonna do that with this one here. The bulb, this thing down here. Ah, okay. Okay, right click, you can change the color, okay. Wait, I'm not getting the. Huh.
Yeah, that didn't work for me.
Yeah, where do you, oh, there it is, okay. I'm not getting colors, I'm just getting black. What? It must be because of some other setting I had, I don't know. Oh, look at that. Oh, that's because it's totally darked out. So if you lighten it up, then you can say, I like deep blue purple. Ooh. Okay, that's scary. All right, it's like 1 minute from end of class. I'm going to, anybody have questions? Have any issues here? I'm going to just run really quickly the beginning of this, and maybe I'll redo it when I make the solution video. Node size by degree, in degree, which is influence, because like I said, the if this actor read that threaded discussion, then it's going to point to that threaded discussion. So in degree is the right influence. Color by entity type, choose a good layout. I'll just do this really quickly, but then we're going to have a problem that I will record in another video. Yeah, node size by in degree, which is influence. I might color by entity is the type of thing it is. For some reason, I've gotten stuck on, I like actors to be red, and The other one's gonna be green and blue. I always make actors red. So that is obviously an important room where a lot of stuff happens in. Here's another important room. And then we might do a layout. This is just gonna run a couple of minutes and I'm gonna redo it recorded later on. So there's an open org layout and then I might, it pulls out the clusters pretty well. And then I might just do a force atlas to prevent overlap. Briefly, whoops, it's pulling it in too much. You can experiment with different things. Their Linlog mode's a little bit better. Sometimes you get this migrating node phenomenon where it's a dynamic system. The layout algorithm is a dynamic system and it might not settle in. It might just keep just wandering around. You know, as it gets too far away, it might get pulled back. This node here is pushing it away because they repel. Anyway, suppose you got that far, and then some challenges I have in the for you to try to solve later. Can you change? Let's make the label actor here. I've got different colors, so I'm going to hit turn the label on, and the label is whether it's the idea of the discussion in the room with the person. So of course the easy thing to do that, if you want to, who's the actor who owns that room or whatever, you can do it that way. So even though we know that this is a room, it was a room that was created by admin, that's the owner of the room, and so on. So suppose you wanted to export this and we hit refresh. So here's the first problem to solve. Okay, what's going on here? I'll give you the solution now and I'll give you the solution to the other two later. You have to rescale the weight. Because the weights are like scaled on the edges, are scaled to fill the whole screen. These are filling the whole screen. The other two solutions that I'll ask you to try, and I'll send a post maybe tomorrow, a solution is, can you make the arrowheads visible and can you change the label to actor here? So if I show label, it's these numbers still. It's not, even though I changed it to actor in the overview, it's numbers here. And the other thing is, I can't see the arrowheads. Why not? This is something that drove me crazy. Try to solve that. Okay, so I'm gonna stop sharing and stop the class, and I will hang out for people who have anything.